You guys, I'm actually done. We're going to do mean value theorem on Monday.
So we're not doing the absolute value problem.
Whatever. Okay, so again, we're trying to find the average value of the function is the height of a rectangle that represents the total area in an interval. Okay, and if I divide by the base, which is like essentially the distance between my bounds, that'll tell me what is the average height of that. Okay, so the integral tells me the area of the rectangle, and then if I divide by the base, I get the height of the rectangle, which is the average of the value of the function, yeah? Okay. So, and then there also exists the x value c that makes that happen. So let's kind of go through, let's start with just finding the average value of a given function. So if I want to find the average value of x squared minus 1 on the interval 0 to square root of 3. So first of all, x squared minus 1 looks like this, yeah? Here's 1. So let's say this is square root of 3. So we're essentially finding the average value of this function, yeah?
Yeah.
And this would be 2, I believe, yeah. Okay, now, so to find that average value, I am going to do 1 over the square root of 3 minus 0 times the integral from 0 to square root 3 of x squared minus 1 dx. Everybody good? Let's see, that would be x cubed over 3 minus x evaluated from 0 to square root 3, yeah? Yeah? You guys, what is the square root of 3 cubed? It would be, and then technically we're subtracting 0 minus 0, yeah. So I have 1 over root 3. Did someone say 3 root 3? Are we comfortable with calling root 3 cubed 3 root 3? Over 3 minus root 3. So what does that make the average value of the function? Does that feel weird?
1 minus 1.
Yeah.
I don't like that.
What's happening? That would imply that the total area under this is in fact 0. Is that okay?
Feels
Yeah, like, you guys, the reason I'm asking this question is it doesn't feel super to me right now either. You know what would be interesting? Is essentially, it doesn't seem absolutely crazy to me that the area is 0 because I think, well, what do we know about this area? It would be negative. And this area would be positive. So is it possible that those two areas are the same?
Possible, yeah.
And in fact, there's...
Check.
It seems very reasonable that Miss Meister's picture is not to scale, yeah?
Yeah.
So can somebody... Why don't we do this, just for funsies? Let's... Are you guys comfortable with me saying that this is 0 to 1?
Yeah.
So what is the integral of x squared minus 1 dx? And you guys, you can use Math 9. Can somebody help me out with that versus 1 to square root 3 of x squared minus 1 dx? So somebody do the first one, somebody do the second one.
The first one is negative 0.6 repeating.
Negative 2/3, yeah.
The other one's 4 times 10 to the negative 14th. So
This one is?
It's 0.6666.
no, the 1 to root 3. Oh wait.
Yeah,
One,
that is.
Sorry, I had 0 to root 3. 1 to root 3 is.
1 to root 3 is 2/3 as well.
So are we starting to understand what's going on here?
Yeah.
Make sense?
Yeah.
So even though it feels icky, did we do it right?
Yes.
Great. Now, there's nothing about this question that says to do this. I just happen to have looked at your quiz recently. And trying to be kind. If I were to say, find the value of C guaranteed by the mean value theorem for integrals. Here's what I know. F of C equals the average value of the function. So in this case, f of C would be C squared minus 1 equals 0, because the average value was equal to 0. Average value of f. So C would equal in this case 1 and negative 1. However, the value that is guaranteed by the thing is inside my interval, so the negative 1, while it's yes makes it equal to 0, is not the one I'm looking for.
So you just plug in C for X and solve for sigma equal to whatever you found. Is that
The average value, yeah. All right, you guys want to find the average value of this one for me, please? Did I do okay so far? Oof. What would you guys do from here?
Just distribute the 1 over E.
Before I do that, what is ln of E?
1.
And man, you know what we might look at if we wanted to? Could we expand ln of 2E to ln of 2 plus ln of E? Using those log properties that... I don't know why, but I feel like that... Because yeah, look at that. And now I have a ln of 2 over E.
I usually like that.
Is my average value of the function, yeah. I think that looks a little bit nicer than ln of 2E minus ln of, or minus 1 all over 2E, all over E, right? It looks a little bit nicer. And more importantly, if we go back and do that find C that Meister might make us do on the quiz, I don't know. That doesn't sound like something she might do, right?
No, not at all.
Then I would say, I think it's a lot easier to solve 1 over C equals ln 2 over E. I think that's easier to solve. Because it's almost like you could just flip both of those. That's a much easier problem to solve, I think. But what do I know? It's not like I know it's going to be on the quiz or anything. How are we feeling about average value of a function? Great. I want to mention second fundamental theorem of calculus. About the second This part should be easy, but as long as you don't make it too challenging, we should be fine. Okay. The first thing I want us to do is take this function. So keep in mind, g of x is a function of x that is an integral with respect to t. Is everybody with me?
Yes.
Okay. And so when I take this integral, because my bounds have an x in it, this integral the result of this integral will be a function in terms of x. Are we feeling okay with that? Okay. You guys, what is the integral of cosine? Is it negative sign?
Oh, wait, no, it's just...
So sine t, and then we'd be evaluating that from x to 1. So in reality, that becomes sine x minus sine 1. Everybody good? So you guys, the question becomes, if I took the derivative of g of x, what would I get? So far, are we feeling okay? All right, let's look at another one. What's the integral of cosine? negative sign. We'd be evaluating from x to 3. So really, h of x is equal to negative sine x minus negative sine t, sine of 3. So really plus sine 3.
Wait, when the
Negative
last
sine.
one is just sine and this one's negative sine?
Isn't it also just sine?
Like in the last one.
Oh, yeah. Like that. You guys, what is this derivative?
Same thing.
Okay, so the first thing I'm going to point out.
Do we need to have like plus c?
No, we don't. Because the minute when we do the definite integral,
Mm-hmm.
so technically that plus c is here. And then I have sine of x plus t minus sine of 3 plus t. Sine of x plus c
Mm-hmm.
minus sine of 3 plus c.
Oh, and then you
And
just
the c's
divide
cancel.
it.
So when you apply the bounds, that plus c goes away anyway.
Okay.
Because whatever that c is, it's the same c for both ones,
Okay.
and you subtract it. Okay. So, are you guys with me that so far what we've done is we've taken the derivative of an integral, essentially. Right? We took the integral and then took the derivative of the function that was that integral. Okay, great. Let's look at this one. All right, so what is my function for r after I apply my bounds?
Sine of x squared minus sine of 6.
Okay. And then what is the derivative?
2x cosine of x squared.
2x cosine x squared. Is this feeling okay? All right. What about this one? After I apply the bounds.
One half x. So negative 1.
Are we feeling okay so far? All right, so some things that are worth pointing out here. You notice I used the same parent function every single time, right? Okay, and in some respects, we integrated cosine, and when we took the derivative, we came back to cosine, and that should feel pretty decent, yeah?
Yeah.
Okay, now, comparing these first two, whether or not this was a 1 on the bottom or a 3 on the bottom, did that matter? No. So if I'm taking a derivative of an integral, where that integral creates a function, the constant doesn't matter because I'm going to take that constant term. What's going to happen is when I apply those bounds, it's still going to be a constant. So when I take the derivative of that constant, it's 0. Is everybody good? likewise, and then when we move down to this one, that what is the difference between the bottom two here and the top two?
The upper bound is just x.
The bound in and of itself is a function. And so it's almost like the bound is an inner function. So to take the derivative, we still left it as plugging the bound in, but we had to multiply by the derivative of that bound because that bound in and of itself is an inner function. Okay. What that really means is, let's say I gave you, asked you to take the derivative of an integral, such as this one. Okay. Well, the derivative and the integral it's almost like they cancel each other out in the same way a squared and a square root. They're inverse operations, yeah? So this will become the sine of 3t. However, I had an inner function when I took that derivative. What was my inner function? It was 3x, so I have to multiply by the 3 out front. So this 3 is the derivative of 3x. So it's a chain rule question. When the bound is just x, you're plugging in a function and taking the derivative. When the bound is x squared, you're plugging in a function, taking the derivative. But now when you take that derivative, you've plugged in x squared, you multiply by the derivative of that other function. Is this okay? Okay. So, you guys, what would this answer be? So the first thing we would do is just plug in 1 plus secant of 5x squared. And then chain rule says you got to multiply by the derivative of that 5x squared. Now, should this have a plus c? Because it's a derivative, right? Also it has bounds, so the c would have gone away anyway. So the derivative of an integral is itself times the derivative of the inside function, which in this is derivative of the bounds. Is everybody good? Tomorrow you'll have, at the beginning, I'll do U sub. And then the second half will be time to have, like, what I would normally give you is quiz review time. So the second half will review for the quiz. That way what you're reviewing is fresh. Does that make sense?